All right, welcome. In this video, we're going to talk through a couple of the important gas variable relationships that we looked at in class. And I like using this PhET simulation to kind of help explain what is going on. So let's get this started by adding some particles to our mixture. And we notice here we can read the pressure. And it looks like the pressure right now at this temperature is around 6, somewhere between 5 and 6, kind of fluctuating a little bit. And let's look at the relationship between volume and pressure first. So if we were to decrease the volume, let's see what happens to the pressure. So right now the pressure is somewhere around like 5 to 6. If I decrease the volume, notice how my pressure went way up here, right? So my pressure is now up at like 11 or 12. So as you decrease the volume, you're going to increase the pressure. And that is because you have more collisions here happening. So if you notice that what causes the pressure at a molecular level, or I should say maybe at a particle level, is that the gas is made up of these little particles that are in constant random motion, so they're constantly bumping around. And it's that collision of those gas particles with a container that's what causes the pressure. So when you cram those particles into a smaller space, they're going to bump into each other more often. So you get the same particles, they're moving at the same speed, they're just colliding more often. And we'll notice that if we increase the volume like this, then we will see the opposite effect. Now they're more spread out, they're going to collide less often. So if you increase the volume, that is going to decrease the pressure because there are going to be fewer collisions. All right, so that's looking at our pressure volume relationship. And notice how we're only ever changing one variable at a time. So the temperature remained constant this whole time and the number of particles in our container remained constant. So you only want to make sure you're only changing one variable. Okay, so we're going to restart this. And this time, let's look at the temperature-pressure relationship. So this time I'm going to hold volume constant, and I'm going to heat it up. So again, right now our starting pressure is around like 5 or 6. I'm going to heat it up. And I'm going to watch these gas particles go. So if I heat it up, we should notice that these gas particles are going, significantly faster. So as we increase the temperature, the particles move faster. So you end up with more frequent collisions. And the collisions also occur with more kinetic energy. So you end up having like more forceful collisions as well. More forceful collisions. And both of those things are going to cause an increase in pressure. So notice the pressure is now around 12. Remember, it started out at around 5 or 6. And then the same can be said if we were to decrease the temperature. We will notice the pressure will drop back down. See, now it's way back down here to 3. So this right here is an example of a direct relationship. So as temperature increases, so does the pressure. And then our one here at the top, pressure volume, this one is an inverse relationship. So as one goes up, the other one goes down. So that's a summary of a couple of the important relationships to know with our gases.